Today we're talking about functions that are defined by equations. You have done this stuff before. They're just going to use different notation, and it's going to look just a little bit different. So our goal is we're going to find the range of each function. So remember what we talked about yesterday? The domain were my x values. The range are my y values. Or the domain, my x values are my input. It's what I plug into the function. So in the bell work, it was 2. My domain was 2 because that's what I was plugging into the function. My range is what I got out of the function. Okay? So I have 6 of these for you. Okay, so we're going to be given a function, and it's going to look a little funny. So we have a function f. That's what that means. Function f, and we're going to define it, and then they have x and then an arrow, and it's going to say 3x minus 2. I told you yesterday that a function is a rule, okay? So this is my rule. That x and arrow really doesn't mean anything. Let me look up real quick so I can tell you how exactly you say that. Function f that assigns x to 3x minus 2. If you care, that's what the arrow notation means. So function x is going to assign x, any value of x, into this equation. Okay? And then they're going to give us a domain. So they're going to say, okay, well, the domain for this function is -7, 0, and 5. Okay, remember my domain were my x values. What do you think I'm going to do with those 3 numbers?
Plug them in for x.
I'm going to plug them in for x. The easiest way I found to do this is to make a table. So the members in my domain are my x values. So I'm going to have a column for my x values. And then I'm going to write my function or my rule. And down the column of my x values, I'm going to write the members of my domain. So I had -7, I had 0, and I had 5. So if I plug 7 in for x, I'll have 3 times -7 minus 2. Okay, well, 3 times -7 gives me -21. -21 minus 2 gives me -23. So there's one member of my range. Okay, if I plug 0 in for x, I have 3 times 0 minus 2. What is 3 times 0 minus 2? -2. And finally, if I plug 5 in for x, 3 times 5 minus 2 gives me 13. So it asked me to find the range. So my range is -23, -2, 13.
But there's a catch.
There is no catch. This information, this function that assigned x to 3x minus 2 in the domain, this is all the information they're going to give to you. So this is what's going to be in your book right here. Okay. That's the information they give you. This is your answer. Okay? Let's do another one.
Do you even need to put the chart?
If you don't need the chart, you don't have to, but I'm telling you, a lot of the equations are going to be a lot trickier than that. So sometimes it's really helpful. Like this next one, if I have function f that assigns t to 4t minus 3. Okay, I lied. This one's not much harder. This time, my domain includes 0, 1, 2, and 3. Okay, so remember, my domain are usually my x values. This time, they're going to be my t values. So I'm going to have my domain column this time is going to be the values of t. And my rule is 4t minus 3. And I'm going to plug in 0, 1, 2, and 3. And if I start with 0, 4 times 0 minus 3 gives me -3. When I plug in 1, 4 times 1 minus 3 gives me. And when I plug in 2, 4 times 2 minus 3 gives me 5. And finally, 4 times 3 minus 3 gives me 9.
Yeah, that's pattern.
It is. So my range is -3, 1, 5, and 9. That's so much. I ask so much of you guys. I know. Okay, this time I have function g that assigns x to 4 plus 3x minus x squared. This just means it's function g. They're giving the function a name. Before I had function f, now it's function g. It really doesn't mean anything at all. This time, my domain is -1, 0, 1, and 2. These are the ones where I'm really going to recommend. If you don't think you need to make a table for the other ones, that's fine. But for these ones, I'm telling you guys, the table is going to be very handy. So if I make a column for my domain, and then I fill in my rule, my values of x, I have 4 of them in my domain. Okay, if I start by plugging -1 in for x, you have to be really, really careful because x is in 2 different spots. There's an x by the 3x, and then there's an x squared. You have to plug -1 in both places. Anywhere you see an x, you've got to replace that with a -1. So I have 4 plus 3 times -1 minus -1 squared. I'm also going to recommend the use of parentheses because they're going to be very handy. Okay, so if we simplify the things we know, 4 plus 3 times -1 gives me -3 minus -1 squared. What is -1 squared? -1 times -1 gives me a +1. Gives me a +1. What is 4 plus -3 minus 1? 0. It's 0. Which one? Nope, because I have to take -1 squared first because it is an exponent. I have to take exponents before I subtract. Okay, when I plug in 0, I have 4 plus 3 times 0 minus 0 squared, which gives me 4 plus 0 minus 0, or just 4. When I plug in 1, I have 4 plus 3 times 1 minus 1 squared, which gives me 4 plus 3 minus 1, which is 6. And finally, when I plug it in for 2, 4 plus 3 times 2 minus 2 squared, I get 4 plus 6 minus 4, which is also 6. Notice that I got 2 of the same values for my output. Remember we learned yesterday? That's okay. That's okay. So my range for this function would be 0, 4, and 6. You do not have to write that 6 twice. Okay, questions about these types? Okay, there's another way that we can kind of write these, and instead of giving you a set of numbers in your domain, I'm going to give you a function. So we have function g that assigns x to 4x minus x squared. Okay, so this is my function, and instead of giving you values, a domain, I'm instead going to ask you to find g of 1. I don't want you guys to get too confused about the notation. Whatever number's in this set of parentheses, you're going to plug it in for x. That's it. Whatever number's inside this set of parentheses, you're going to plug it in for x. It's basically giving you your domain is 1. For these equations, they're going to say, okay, your domain is all real numbers. So if you know your domain is all the real numbers in the entire world, I want you to find the value when x is 1. Okay? So you can kind of think about it. Okay, if my domain is 1, I'm going to plug 1 in for x. But your domain is actually all real numbers. You're finding one specific value. So if I plug 1 in for x, I have 4 times 1 minus 1 squared, which is 4 minus 1, which is 3. Okay, what if I want g of negative 1? Okay, well now I'm going to plug negative 1 in for x. So I have 4 times negative 1 minus negative 1 squared. Remember, we do exponents first. So I have to take negative 1 squared, and negative 1 times negative 1 gives me a positive 1. So I have negative 4 minus 1, which is negative 5. And then finally, let's find g of 2. So if I plug 2 in for x, I have 4 times 2, which is 8, minus 2 squared, which is 4. So g of 2 gives me 4. Just looks a little different. Okay, let's do one more together, and I'll give you one to try on your own, and then you can work on your homework. Okay, this time, I've got an equation, and we're going to say f of x equals x squared plus 1. This is just another way to say function f assigns x to x squared plus 1. They're just leaving out the arrows. This is probably the more common way that you'll see it down the road, and they say f of x equals x squared plus 1. If I want to find f of negative 1, what do you think I'm going to do? I'm going to plug negative 1 in for x. Negative 1 squared gives me 1, and 1 plus 1 gives me 2. If I want to find f of 0, I'm going to plug 0 in for x, and I get 1. And finally, if I want to find f of 2, I'm going to plug 2 in for x. I get 4 plus 1, which gives me 5. Is this making sense? Easy as I promised?
No.
Partially.
Partially. Okay, you guys try this one. Okay, I want you, for function f that assigns x to x squared minus 2x, I want you guys to find 3 values for me. I want you to find f of 4, f of negative 3, and f of 2. Okay, what did you get for f of 4? 8. 4 squared gives you 16. 2 times 4 gives you 8. So it is 8. F of negative 3 was kind of tricky. What did you guys get for f of 3? Negative 3. Should have got 15. Negative 3 squared gives me a positive 9. Negative 2 times negative 3 gives me a positive 6. And 9 plus 6 gives me 15. And what about f of 2?
0.
Should have got 0.